Let us evaluate the double integral. We will do it by changing the order of integration. Observe that x is changing from x equal to y to x equal to a. Let this point be a comma 0 and let this point be 0 comma a. Then this point must be the point a comma a. Now x equal to y, that's a line passing through a comma a and the origin. Let's draw the line x equal to y. Once again we observe that x is changing from x equal to y to x equal to a. Let us draw that region x equal to a, that's a straight line parallel to y-axis. And we did it. What about x equal to y? That we have already done it. X equal to y, that's again a straight line at an angle 45 degree. We need to change from x equal to y up to x equal to a. So we need to change x equal to y from x equal to y to x equal to a. So we want to do double integration over the shaded area. Let's try to do it differently. So once again we draw the line x equal to y. Once again we got the point a comma 0. Once again we got the point 0 comma a and we draw the line x equal to y. So we need the point a comma a. Yeah, we got it, the point a comma a. Now we draw the line x equal to y or y equal to x. Okay, so far so good. Now we want to somehow cover this area. So let's mark the area. And instead of changing from x equal to y to x equal to a, let us change it from y equal to 0 to y equal to x. Once again, if we change from y equal to 0 to y equal to x, then we will be exactly getting the same area. Are the shaded areas same in both cases? The answer is yes. So the region of integration remains the same. So integral will also be equal. Once again, region of integration is same. So integral will also be equal. That is integral 0 to a dy and then y to a x by x square plus y square dx is exactly equal to, we are changing the integral from y equal to 0 to y equal to x. Once again we will be doing this time the integral y equal to 0 to y equal to x, that's the inner integral, and then y equal to 0 to y equal to x, that's the inner integral. How about the outer integral? Outer integral we will be doing from x equal to 0 to x equal to a. Outer integral is x equal to 0 to x equal to a. How about the function? The function is x by x square plus y square dy dx. Now you see that integral is much simpler because we will be regarding x to be a constant when we are integrating with respect to y. So once we regard x to be constant, we can take it out of the integral, the inner integral, and then we got the formula that integral of 1 by a square plus y square dy is simply equal to 1 by a tan inverse of y by a. Let's apply that. So 1 by x, well, we can cancel x as well. Tan inverse of y by x. We don't write the constant of integration, but we write the limit y changing from y equal to 0 to y equal to x. Lastly, we need to evaluate the outer integral. X is changing from 0 to a dx. So far so good. So we can cancel x out when we write the upper limit. Tan inverse of 1, that's just pi by 4, minus tan inverse of 0 is 0, and we will be integrating from x equal to 0 to x equal to a dx. And that's simply equal to pi by 4a. Can it without interchanging the order of integration. Well, it may not be possible, however, you might be able to do it using polar coordinates.